Okay, so now what we're going to do is talk about dividing complex numbers. So before we talk about dividing complex numbers, let's talk about dividing real numbers. So if I had 8 divided by 4, what I'm asking for this case is asking how many times does 4 divide into 8? Well, we know that 4 divides into 8 2 times. Now, let's kind of get a little bit more tricky, and let's say, well, what about if I have 8 divided by 3? Now, 3 does not divide into 8 evenly. We know that it goes into there, it divides into there 2 times, right? But then we have a remainder of also 2. And so we could rewrite that as 2 with the remainder of 2/3, right? If we were going to use this as a mixed number, or you could do a decimal version, which would be 2.666 ... that goes on and on and on forever. So we just cover this over, right? It's going to be repeating. So it doesn't evenly divide into there. Now, let's talk about, so therefore repeating fraction, but then let's also talk about irrational numbers, right? These are at least whole numbers, okay? But what about if I took 8 and I divided by the square root of 2? Now, square root of 2 is an irrational number, meaning that it goes on and on and on forever. So here, I could at least divide these values into it and get a number, and even though it might have a repeating decimal with it, I could at least divide it into. But square root of 2, how many times is that actually going to divide into 8? Because remember, that number, we can't actually grip a hold of it like we can for 3 and 4, right? So what we'd like to do is, rather than trying to find an exact answer with this, because we can't, because this is irrational, it goes on and on forever, what we do is we simplify it. And to do that, we cannot divide by, we don't want to divide by the square root of a number. So we eliminate the square root by multiplying by the square root of 2 on the top and bottom. Since we're multiplying this fraction on the top and the bottom, we're keeping what we call equivalent fractions. Therefore, we have 8 times square root of 2 divided by 2, which now can be simplified to 4 times square root of 2. So that's what we call like times our simplified answer. Now, the same thing can be said in 8 over I. I, we can't even write I unless we're using a complex, we can't even plot I unless we're using a complex axis. So I is our imaginary unit. So how are we going to divide I into 8? Well, the exact same way that we deal with irrational numbers. We want to eliminate I in our denominator. So to do that, we multiply our numerator and our denominator by I. Therefore, we have 8I divided by I squared, which is -1, which gives us a simplified answer of -8I. All right? So that's going to be our purpose when we're going to look into dividing. We're going to do something else that's also going to be talking about multiplying by our conjugate, which I'll get to as well. But our main focus for this is going to be eliminating the I off the denominator. Because unlike when we have a real whole number in our denominator, we can divide it evenly into it. We can divide 3 into it, and we're just going to still have an answer. It'll just be a repeating decimal. However, when we have irrational numbers, that causes problems for us dividing into it, and it's going to cause real problems when we're dividing imaginary numbers. So what we like to do for these two is eliminate our imaginary or irrational number in our denominator to simplify the solution. So there you go, ladies and gentlemen. That is a brief little overview of dividing complex numbers. Thanks.